Hello and welcome to lesson 8 of JavaScript. In this lesson, we are going to look at numbers, the number methods and properties. My name is Mildred. In JavaScript, numbers are written either as whole numbers, let's say let x be equal to 1, 2, 3, or we write as decimal number. There are no different data types, we just have the number data type in JavaScript, and they are always 64-bit floating point numbers, and which means that we have a legal range of minus 2 raised to the power of 53 minus 1 to 2 raised to the power of 53 minus 1. And so that is the range of the legal numbers, and so the numbers can have up to 15 digits and 17 in decimal. And so after that, the system no longer recognizes this as a number because it is too large and it becomes a big int. But with JavaScript, you have to specify big int, and we write big int using big int like this, and then we put a number here so that the system can use this number as we want it to be. Big int is not a number type, it is a type of big int. And so let's illustrate this. I have a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, which is 10 digits, so I'll make it 17 digits. When I save this and I print out X to the page, I refresh my web page, I will have the number printed out to the page. You see that the last number is already rounded up because I used more than 15. But by the time I change this to just 15 and I refresh, I will have exactly what I have printed on the page. Now, we can't have more than 15 digits of integer numbers or whole numbers with the number data type. And if you want to have a big int, you can put an n at the end. So let me write 6, 7, 8, 9 and use an n at the end. When I save this and refresh, it sees this as a big int, and so it prints out what I typed. But if I remove the n, it is not going to be the case. So once we have above 15 digits, it begins to print out something that is not accurate because the number data type in JavaScript only allows 15 digits for the legal number range and 17 for decimal. There's another way you can use big int. You can put the big int method like this, and in the parentheses you put the number. Now big int, it is not of the number data type, so when you have big int, you can have decimal number. Big int doesn't support you to do arithmetic operations between a number that is a big int and a number that is of a number data type, so take note of that. When you have numbers that are greater than 15 digits, you want to put an n at the end or put it in the parentheses of the big int method to let the system know that this is outside of the legal range of a number type in JavaScript. So we have said previously that the plus sign that we use for arithmetic operation adds two numbers together. When we print x, we are going to get 9 on the page. But when we want to use the plus sign with strings, it will concatenate instead of add. So let's make this a string, and so instead of now adding these two, it is going to concatenate. So I'll say let x be equal to 4, let y be equal to 5, and then let z is equal to x plus y, and this is going to give me 4, 5, 45 when I print out to the page because it is strings and it concatenates instead of add them together. So when I change this and remove the quotes, it is going to add them and it's going to print out 9 to the page. So take note, when your number is of the string data type, arithmetic operation will concatenate, but other operations will work as expected. So because JavaScript will attempt to convert this, so when I say 4 times 5, it's going to give me 20 because the other arithmetic operations will work fine. Just the plus sign that has two uses that has that issue with strings and numbers. So when I multiply this, I'll get 20. Without the quotes, I will still get 20. So take note, when you're using the plus sign in JavaScript, plus means two things: either you concatenate strings or you add integers. And because of these two functions, it is always going to merge strings together rather than add them. So we have another number data type which we call nan, not a number. And you'll see this along your programming journey, because sometimes you will have things that are not a number. If you attempt to do operation with things that are not number, let's say this is 4 and this is a string called color red, and I attempt to do z is equal to x times y, and I'm going to get nan as my answer, telling me this is not a number. So when you see this, it means that you have used an illegal number type along with a number type to perform an operation, and the system is telling telling you that the result is not a number. You also have another number type, which is infinity. Like we try to do division by 0. Let's say 4 divided by, so x divided by y. This is going to be infinity because we are doing division by 0. So we have positive and negative infinity, and we'll see that a little later. So in JavaScript, when you write numbers, you try not to precede numbers with zeros like this. Although it's correct, is because we have numbers that take hexadecimal, octal, binary, and when the default is decimal. Octal always has a leading 0. Hexadecimal will have 0x like this, and then we have the binary that will have the b. And so you don't want to put preceding for a number in JavaScript just to make sure there's no confusion between the decimal or is in base 10 or it is an octal number. So now let's look at the different methods we can use to manipulate numbers, or different methods we can use with numbers to do different things, and then we're going to look at the properties. Now in number, we have a method called toString. If I want to convert x to string, I'll say let y be equal to x dot toString like this, and then when I decide to say let it be type of, I want to get the type of y, and so it's going to print the type of y is going to be string for me when I refresh my page. So y is a string. So you use the toString to convert a number to a string. We also have a method called toExponential like this. For instance, I have 4.2 like this. I want it to 2 decimal place. I can put to exponential 2, and then I'll print out y. Now let's look at this to 2 decimal place first, and then we have it to 2 decimal place but gives me in scientific notation. So to exponential will convert your number into scientific notation, but you can specify a number here to tell you how many decimal place you want your number reduced to, and without specifying that, all you get is converting what you have to scientific notation like this. So we have another function called a toFixed. Now toFixed is what we use to specify the number of decimal places. We write it like this, toFixed, and then now we can put, we want this, let me put this to, or add more numbers here. I want this to be to 3 decimal place, so I have 4.678, so I can put toFixed 3, and this will give me my number rounded up or down to 3 decimal place. We have another method called the toPrecision method. So you see the methods are a little similar, but there are slight differences to when we need them or when we use them. And when we use toPrecision, we want to specify now not the number of decimal place like the toFixed, but the number of digits that we want on the page. So let's say I want 2 digits, so I'll end up getting 4.7 because it's going to round up and give me 2 digits, 4.7. If it's less than 5, it will round down and give me 4.6. So you know how round up and round down works in mathematics. So I'll save this, refresh, and I'll get 4.7. But in the event where this is lower than 5, let's say 4, it will give me 4.6 when I refresh my page. And so this is how we use the toPrecision. So we can try to look at the value of method. We have the value of method. Let's say we have this to be 567, and I put x dot value of, and then I want to print out y to the page. So when I save and I refresh, I'll see 567 there. So you have to know what the slight differences are between the different methods so that you can use the appropriate method for what you need to do, because the value of just returns a number, has a number to use. So if this is a number, it returns the number back. So we have JavaScript is now modularized, and so we have global methods before that are now modular, like we have the number dot something, number that, so it's now from the number module. And so when we want to use this kind of numbers, we begin to append with number dot something because we know where we're getting it from. So we have the number method written like this that we use to convert JavaScript variables to a number. So let's say I want to convert this variable to a number. Let's make it with it, and I'll put the number here, and I'll put y is equal to x, and here I'm going to put x. It's going to return it. So I'll save. It's going to return the exact string but as a number. And if I decide to print, like say z is equal to type of, I want to look at the type of y, and when I print out y, or I print out z, let me use let here, I'll get it is a type of number because I have used the number method to convert it to a number. So if you like, for instance, we have Boolean, and in computer, true is represented by 1, false by 0. And if I decide to say number true is going to return 1 to me when I want to print out y to the page. And if I do false, it's going to return 0. If I put something that is not a number, it's not a string, it's not of anything, it will return not a number. For instance, I put something like 10, I'll put a comma 000, and then when I try to print this, I should get none, not a number, to the page. So I'm printing out number X. Save, refresh, and I'll get not a number. So this is what we use the number method to do. So we can also use this to convert a date to a number. So if I say number new date, so we use a new date. I'm going to show you how to use the date method in next week's lessons, but let's say we have new date 1980, let's say September. When I save this and I refresh, it's going to bring the representation of that date. We have a parseInt method written like this. So what we use the parseInt to do is to return a whole number. So let's say, for instance, I want to pass this as an integer. I have written X is equal to, let's say we're talking about somebody who is 30 years old, so I'll put 30 years, and I want Y to be parseInt X. And so when I print out Y to the page, it's going to print out just a 30 because it just gets me the number out of that string. So if we are using decimal number, we can change this from parseInt to parseLoad like this. Okay, so let's look at the different properties that we have in JavaScript. We have a property called epsilon, and so in mathematics we know what this is supposed to be. Epsilon is the difference between 1 and the smallest floating point number in JavaScript. So we can print out Y and it's not spelled correctly, and so fresh, it gives me that number that is the difference between 1 and the smallest floating point JavaScript number. We can also do things like we want to get the largest possible number in JavaScript. We can put max, and it must all be in caps _value. When we print this to the page, this is not the use of it, but I'm just trying to print out what the numbers are for you to see. So when we print this on the page, we get a number. You can change it to min to get the minimum number. We want to look at the max save integer, for instance. Let's say the maximum save integer. We can print that to the page, and to give you the maximum save positive integer we have, we can use min save integer to get what the minimum is, like this. Save, refresh, and we have the min save integer. We can also want to print out positive infinity, which will print out infinity to the page, negative infinity, minus infinity, and we can print out none, not a number, to the page. So these are all the numbers and number methods that we have in JavaScript. Thank you, and see you in the next lesson.